Merhabalar, bu videoda da C# üzerinde kendi yazdığımız Network Simülatörümüzü tanıtacağız. Öncelikle Microsoft Visual Studio üzerinden programımızı çalıştırıyoruz. Şimdi karşımızda böyle bir GUI'miz var. Buradan not size'ımızı ayarlayabiliyoruz. Yani kaç tane not istediğimizi. Şu an için 10 tane yeterli bizim için. Not radyusumuz ise not genişliği, yani notlarımızın kapsadığı alan. Buradan enerjimizi de ayarlayabiliyoruz. Bunu da 20'de tutalım. Not enerji, notlar birbirine mesaj gönderirken receive ve send ettikleri mesajlar kadar enerjileri düşer. Bunları ayarlayabiliriz oranlarını. Distance'ımızı seçelim. Not distance ise notlar arasındaki uzaklığı belirtiyor burada. Notlarımızın connected notlar olması lazım. Yani birbirine bağlı notlar olması lazım. Bunun için de BFS algoritması uyguladık ki garip şekiller birbirine bağlı olmayan notlar çıkmasın. Buradan da onun sayısını değiştirebiliyoruz. Yani 10 kere bu algoritmanın üzerinde BFS algoritmasına bağlı olarak connected graph yaratmaya çalışıyor. Yaratamazsa bize bir mesaj verecek, connected graph yaratılamadı diye. Deploy network'e basaraktan notlarımızı yazalım. Evet, şu anda gördüğünüz gibi bütün notlarımız birbirine bağlı. Üstüne geldiğimiz zaman ID'leri çıkıyor. Çift tıkladığımızda ise notların enerjileri, node ID'leri, koordinatları ve onların child'ları, yani neighbor'ları çıkıyor. Ondan sonra Basagni algoritmasını kullanarak bizim implement ettiğimiz algoritma Basagni'nin network algoritması. Basagni algoritmasını kullanarak sonuca ulaşmaya çalışacağız simülatörümüzde. Tıklıyoruz Start Senkronize butonu ile. Tıkladık. Evet, şu anda işlemleri yaptı. Thread ve queue class'larımız var. Bunları senkron bir şekilde yapabilmek için. Baktığımız gibi burada kırmızı şeklinde olanlar class thread mesajı. Yani kümenin komutanı başı durumunda olan notlarımız kırmızı ile, diğerleri de ona join mesajı gönderen mavi notlarımız, yani ona bağlı olan notlarımız. Burada da gerekli işlemler gösteriliyor. Bunların sıraları her zaman değişebilir çünkü thread kullandık. Threadlerin ne zaman ne yapacağını bilemiyoruz ama algoritma her halükarda bu şeyi çıkartacaktır. Burada istersek Save Network butonundan masa üstüne resmimizi atabiliriz. Onu da bir görelim. Sağ olsun. Biraz bekletiyor herhalde bizi. Evet, şu anda gördüğünüz gibi oradaki notlarımız grafiğimizle burada direkt gözükebiliyor. Böylelikle sunumluğun sonuna geliyoruz.
Hello. In this short video, we are going to demonstrate the interoperability between an NCS 1002 MUX and the NCS 5500, the new router. Shrikant and myself prepared this demo for Ponzi in Rome in November 2015. The lab, we have a Ixia traffic generator on the right, pushing packets into the NCS 5500. The packets will go through a snake, occupying 12 ports among 2 NPUs inside this NCS 5500. Then the packet will be sent through a gray interface to our NCS 1002. Then it will go through the optical network and back again inside the router and finally into the traffic generator. So the lab itself, we have the Ixia here on the right, we have our NCS 5500 in a center. We can see we only use one single line card in the third slot. And this line card is actually 36 by 100 gigi port. Finally, on the left, we have the NCS 1002. This is our MUX connecting both the gray side through client interface and also connecting this line interfaces through DWDM CFP2 optics. So, the demo itself. So for this, what we're gonna try to do is fairly simple. We'll just generate traffic, and we don't have enough ports to have all the interfaces of the NCS 5500 fully loaded. So what we're going to do, we're just going to create a snake. That means we interconnect pairs of ports inside a single NPU. Actually, we're using two NPUs here, 12 ports, and we are configuring it through VRF lights and to force the traffic loop all the way through all these ports. So the traffic after it went through the snake will be sent into the NCS 1002, and it will go through the optical network, and back again it will be sent inside the router, and in that last step we're just going to route from this port to this port back into the IXIA, the traffic generator. I can see I have a 36 by 100 gigi port connected into the slot number 3. This is actually split into 6 different slices, each slices being one single NPU, so it's from 0 to 5. On the NCS 1002, I have the same system. I can see I'm using an iOS XR version 6.0 here, it's still a pre-code, and same on this platform, on Freta. So I'm using a pre-code of 6.0 here. Just having a quick look at the configuration, we just allocate one slice of the Roscoe and we configure the trunk at 200 gigi. We use a soft decision FEC 20, and we connected each slice at a bit rate for the client at 100 gigi. And that's all you need to have here. On the optical device side, you can see that you are defining a wavelength, and that's all you need to do to configure it. It's as simple as that. On the router side, the configuration will be also fairly simple. We are using a couple of VRFs, and all the interface are connected through themselves between the port 12 and 17th, and all these ports are assigned to different VRFs. That's how we are creating the loop. And we have also a couple of static routes also defined to help passing the traffic between all these VRF lights. So it's a very simple configuration, no fancy features, nothing here, just packet forwarding. Let's get back into our ROS NCS 1002 platform. If we check this interface, we can see this is actually the line interface, so one connected to the DWDM network. We see the optical type is DWDM, and we see the frequency and the wavelength that has been configured to it. On the interface, the client interface side, we see we're connected through the port 7 through gray optics. Now on the router side, let's take a quick look at the configuration. We have 2 ports connected to our NCS 1002. Port 2 and 3 are connected to port 7 and 11. And on the center, we have our snake. So all these ports are looped all together. And finally, we have all these ports here connected to the IXIA, 6 and 7. If we can just check the CDP, we can see that the ports are connected to themselves. That's basically the snake. So we can verify here that the port 3 is connected to 2 and 12 to 13, etc., etc. So that's how we are creating our loops, our snake. So now let's take a look at the traffic itself. Here, this is a port where the traffic is coming into the system. So we see we have bidirectional traffic. We are sending this amount of traffic, almost 80 gigi at layer 3, and with this number of packets per second. So if we just take these numbers, and we're going to do the math pretty quickly. Let me clear that. I just take this value here, divided by the number of packets per second, divided by 8, and I see I have a packet size, an average packet size of almost 84 bytes per packet. So that's what I'm sending inside the router. Let's take a look at the traffic generator itself. and we can see on the traffic definition, if I go to this, that's exactly what we configured, 84 bytes. And we are sending line rate. So as you can see, because of the headers and the way we are counting the packet on the router, we are generating traffic at line rate, 99%. But on the router itself, what we see is actually 80 gig of layer 3 traffic, because we are not counting, of course, the headers, the layer 2 and layer 1 headers here. Now, we're gonna see what's going on inside our snake. Okay, this is the traffic now we are receiving on the first NPU, and we are using 6 ports, and I just checked the counters on these 6 ports. I will now add up all these numbers to see the number of packets per second handled by one single ASIC. Let me clear this and now do the math. So I'm sending, if I divide this by 1 million, I'm sending 714 million packets per second on one single ASIC. And this is just one direction. Of course, we have the same, almost the same numbers in the other direction. So that's, in short, I'm pushing 714 packets at 84 bytes layer 3. Now, if I see what's going in out of the system through my gray interface, so this is what I'm sending and what I'm receiving on the other port, of course, all bidirectional. If I check now the counters themselves, so I can see this is using LR4 optics, going inside my Roscoe, my NCS 2000, and I can see for each lane I have my RX power and RX power attenuation values. So traffic now is going through. I mean, we don't have any fancy IP over DWDM communication between the router and the MUX. Of course, it's a MUX. We're just sending traffic through gray interface, and we are receiving them back. But we can see at the performance of the system now.